Welcome again to chapter 1, where we are dealing with computation and numbers. This is the beginning of section 3, lesson 1, where we deal with indices. Right? So what is an indice? That's like a plural form of a word, right? Um, the the base word is index, or the singular word is index. So when we write 2 squared, we know that is a 2 on top of 2. When we write 2 squared, this is called an index. An indices is the plural way of saying index, right? As I said before, it tells us how many times a number has been multiplied by itself. So here, a number is multiplied twice by itself. So it's 2 multiplied by 2, which happens to be 4, right? So 2 squared is 4 because I'm multiplying 2 by itself twice. If I have 3 multiplied by 3 multiplied by 3 multiplied by 3, here I'm multiplying 3 by itself 4 times. So that's 3 to the power 4. And you heard what I just said. I said 3 to the power 4. I didn't say 3, 4, like we're singing a song. I said 3 to the power 4. We say this is 3 to the power 4. Power is another way of saying index, right? I didn't say 3 index 4. We just normally say 3 to the power 4. Now, there are some rules to indices that we have to remember. There are 5 rules that you have to commit to memory, right? And these are the 5 rules. The first rule is that a to the m multiplied by a to the n is equal to a to the power m plus n. And that simply means once we have the same base, so I can't have 2 to the 3 multiplied by 3 to the 4, because 2 and 3, they are different bases. Once we have the same base and they are being multiplied by each other, we can add the indices. So a to the m by a to the n is equal to a to the power m plus n. Number 2, the second rule is that a to the m divided by a to the n is equal to a to the m minus n. So if we're dividing the same base, we can minus or subtract our indices. The third rule is simply that a to the power 1 is equal to a. So any number that you see by itself, it's understood that that is to the power 1. Think about it. It's just a by itself. It's not multiplying itself at all, right? So a to the power n, the power 1, sorry, is equal to a. Anything to the power 1 is itself. And you could see that from what the definition of an index is, right? The fourth rule is that anything to the power 0 is equal to 1, right? Because we're not multiplying itself at all. We're taking it out. So anything to the power 0 is equal to 1. I could have 1,000,000 to the power 0. That means I just have 1. So anything to the power 0 is equal to 1. And the fifth rule is that a to the minus n. So what do we do with these negative indices? What do those negative indices mean? It means that it's 1 over a to the n, right? So you have, it's like a reciprocal. It's 1 over a to the power of whatever is after that minus sign. So these are the 5 rules. Really make sure that you acquaint yourself with these rules, because they are going to be important in working out many different types of questions. And of course, the note here is important, and I would have mentioned it, that the bases must be the same for these rules to work, especially the first and second rule. The base must be the same. So let's look at an example where we work out a few things. We have 2 examples. and I have them on the other page, right? So we have two examples of what to work out here. So let's look at this first example here, which says work out a 2 to the 3 by 2 to the 4. Now you notice that this has the same base, meaning that the base number, the number that has the indice on it or the index on it is 2. So they have the same base. So that means we could apply our first rule, which says when we multiply the same base, we can add the indices. So 2 to the 3 by 2 to the 4 is 2 to the 7. Right, so that's the first one. B says 2 squared by 2 to the 5 by 2 to the 7. Now, not because we have 3 bases means we don't know what to do. The same thing applies. We can, since all the bases are 2, we can add all the indices. So this will be 2 to the power 2 plus 5 plus 7. 2 plus 5 is 7 plus 7 is equal to 14. So that's 2 to the 14. C says 2p by p to the 4. All right, so this looks a little bit tricky here because it doesn't appear that these are the same bases. This base looks like 2p, and this base looks like p. However, when we are multiplying, we are only looking at the same figure, the same base. So for example, if we had something like 2pqr multiplied by 2, let's not use 2, let's use 3p squared qr cubed. Now, these don't look like the same bases because this is p qr and this is by 2 and this is 3pqr and p squared but r cubed. They don't look the same, but what we can do in multiplication is look at those that carry the same base, and that's what we can add and multiply. So we'll come back to this example. Let's finish C. So we are looking at the same bases. That's the p and that's the p to the 4, those two p's. So we put back our constant 2 here. That's not bothering us. We know that 2p means 2p to the power 1. It's understood. Remember, that's our third rule. And multiply by p to the 4, which is equal to 2p. These p's are the same base, so we can add those indices. 2p to the power 1 plus 4, which is 2p to the 5. Look at it here now, even more complex with P, Q, and R. So we are looking only at those that share the same base. So 2 by 3 is 6. We could say this is 6. P, this P and this P, same base. This 1 is understood, or the ones here are understood. So that's P to the power 1 plus 2. And then Q, let's look at the Q's now. This is Q to the power 1. This 1 also is understood, plus 1. And then we're multiplying that by R to the power 1 plus 3. So you see how we could pick out the same base when we are multiplying. So that's 6p cubed q squared r to the power 4. Right? So I hope you see where we are adding the indices only on the same base, right? Okay, not to be confused with terms, which we'll come to when we're doing algebra. So part D says 3x by 4x squared, right? So again, as we did here with our example on the side, we can multiply our constants. 3 by 4, that's 12. And x, this to the power 1 is understood, plus 2. So that's 12x cubed. All right, let's look at example 2, where we have to work out these three things. So A. So let's separate that first example from the second example. So let's look at A. 5 to the power 7. Now we are dividing. And you know when we divide our bases, when they are the same, we have to minus the indices. So this will be 5 to the 7 minus 3, which is 5 to the power 4. B. A to the power 12 divided by A to the power 10. That is equal to A, same base, A, to the power 12 minus 10, we minus the indices, and that gives us 12 minus 10 is 2A squared. And our last example, C, P to the M divided by P to the N. Same base, so we can subtract our indices. That's P to the M minus N. And we don't know what M is and we don't know what N is. So that's as far as we could go with that example in part C. So this is how we work out our indices.